Alright, hey guys, this is March 30th, Monday. We missed you guys. We'll get back into geometry here. So I've tried to condense the material a little bit for y'all, and we'll just kind of go through it. So what would probably be the easiest to do is go through, watch the video as we go through. Then when you start the actual homework portion of it, you can rewind the video and get back to these little sections that we go through. That way you kind of have me walking you through it more than one problem or two. So just do that. If you have any questions at the end, get up with me and we'll figure it out. Today's lesson is transformations. And so basically you're going to be taking a shape or points and moving it to another location in space. And so if you look at the definitions on page 500, we'll look at a couple of the italicized stuff first. And it basically says, in mathematics, the term transformation describes a change in the appearance of points in a plane. It is therefore a correspondence between point locations before and after the change. The geometric figure before a transformation is called the preimage, and the resulting geometric figure after the transformation is called the image. And so if you look up here in the top left corner, I drew two triangles. The first triangle is the one you start with, and so it is identified as the preimage. So triangle ABC is the preimage. Now, when we're going to move this triangle to another point in space, basically what happens is you're going to wind up with A shifting over here, B shifting here, and then C shifting all the way over here. And so what happens is the new figure is identified as A prime, B prime, and C prime, and that is the image. The little tick mark just reads prime, and so when you see A with a little tick mark above it, that just reads prime, which basically denotes where the new image. And so A moves to A prime, B moves across to B prime, and then C moves across to C prime. And since we're not actually changing anything with the triangle, it's going to be an identical triangle. So triangle A, B, and C is going to be congruent, have the same measures as triangle A prime, B prime, C prime. And so that's essentially the big idea for this next few sections, is just moving the different figures. And so this is very important to understand, just insofar as when you take A, B, and C and move it, it becomes A prime, B prime, and C prime. But they're really the same triangle. They're similar triangles, congruent triangles. And so this lesson right here, it says a definition for the transformation is a one-to-one function from plane onto another plane, which is basically what we just did right here. We just moved one triangle and we moved it along in space to another plane. And so that is just the definition. This is the practical imagery of what a transformation looks like. And then you have the actual definition there in your book. Now, today's lesson in particular is going to be on reflections, and so if you look at page 501, you'll see the little box definition of a reflection, which is written right here towards the left on the board. So it says reflection, you have two basic properties. It says if A is on line L, then A equals A prime. So if the actual point you're looking at is on the line of reflection, then that is A prime. It just stays exactly right there. The second property is if A is not on line L, then line L is perpendicular bisector of the segment A prime, which means line L is just going to be basically intersect at right angles with the segment. And so we'll look at that. So here I drew one up on the board. I drew a couple points, A, B, and C, and then I drew point D on the line. And so what happens when we go to reflect something? Basically, you're just going to, if we had a ruler and a protractor, you would just measure out where A intersects D at a right angle. So I would essentially just kind of draw from A to line X in this case, where it intersects at a right angle. Okay? And then you're just going to measure that distance. So if that distance was, say, 10 centimeters from A to the line, then you're going to measure 10 centimeters from the line out to this other side. And so I would just measure 10 centimeters, and then you would have your next point, and you would label that A prime. So the important thing here, the two basic properties that go along with it, is that it's the same distance from A to the line as A prime to the line, and this segment right here, the new segment, A prime, intersects X at a right angle. And so no matter how they arrange it, you're always going to get a right angle, and then it's going to be the same distance. And so if you wanted to do B, you would measure from B to line X, and get, we'll say that's 5 centimeters, and then you would go from the line X out here in space 5 centimeters, and that would be your B prime. And so that point would be right here. And then the same thing with C. You would go from C to your line X, and we'll say that's 12 centimeters. And then you would go from your line X out here in space 12 centimeters, and that would be your new point. So that would be C prime. And then notice D, what I just did here illustrates this bottom one. What D is, D lies actually on the line, and so you just, D prime is actually still right there in the same point. So basically when I erase the dotted lines to show us what I measured, basically your new figure looks something like that. So you have A prime, B prime, C prime, and then D. And they're the same distance from the line as A, B, and C, and they are at right angles with line X. And so that's essentially all you have to do. Now, for us, since we don't actually have a protractor to make sure it's a 90-degree angle, and since you probably don't have a ruler to measure the actual distance, we can estimate that as long as you understand the concept that you basically have the same distance from A to the line as you do from A prime to the line, and A prime and A, that segment that goes all the way across, is going to intersect at a right angle with X, line X. And so that's basically what you're going to do. And so they'll give it to you a few different ways. I did it with points right there. They can do it with pretty much anything. If I had a triangle, we'll draw a triangle, and we'll do A, B, C, and then we'll draw some type of line here. And what I want to do is reflect this triangle. We'll say this is line X. I want to reflect this triangle over line X. And all I have to do is make sure I get at a right angle from a point to the line. And so when I do this, I want to make sure that this intersects at a right angle. And so we'll say that intersects at the right angle. It's not always going to be straight across. It could be. Notice how your line is slanted. And so when your line is slanted, that's going to mean that it's not just straight like this. From A to X, would it be a right angle if you just went straight across? So you would have to use the protractor to find out where exactly this measured a right angle at. We'll say that was where it measured a right angle at. Again, you can estimate it a little bit here, but then we're just going to say, okay, if this was 7 centimeters, then we would do 7 centimeters over here. And so you can kind of estimate it as long as you understand the idea and the concept. And so that would be A prime. Okay, then we're going to go B. So B is right here, so I would have to measure or get the right angle to the line. So I would do B, right angle to the line would be somewhere in here. And so you would measure this distance. Well, if that distance was 3, then I would measure 3 over here. And that would be your B prime. And then your C, you would have to get at a right angle. We'll say that's there. And then you would measure this distance. And if that was 10, then you would measure 10. And that would be your C prime. And then you would draw your new triangle. And they would be the same. And so that's essentially what you're doing. Again, if we don't have the protractor, which I doubt we have a protractor, but if you have a ruler, you can make it a little bit cleaner. But just you can sketch these as long as you understand the concept of it's a right angle, A intersects X, that segment is a right angle, and that it's the same distance from A to line X as from A prime to line X. So that's important. And the last thing they'll do is they're going to throw something up here, like they'll do maybe, we'll do these 2 points, A and B, and then they may throw you A prime, B prime on the board like that. And then what they want you to do is to actually find the line of intersection. So instead of getting the new points, they want to know where that actual line would be. And so again, it works similarly. You're basically looking for the same distance and a right angle. And so there's a few different ways you can get there. One way is you can measure the distance from here to there and then divide by 2 because you have that same distance on both sides. So you can do that, and then you just can use a protractor to figure out where it would intersect at a right angle. So for us, we can estimate it, that's fine, as long as we understand the concept behind it, we can make that a little bit easier. So basically I'm just trying to find a line that splits this directly down the middle, so that this side looks the same as that side, and so that would be somewhere right in there. And so that, I can just draw that and label that line X, and that would illustrate my line of reflection. And so in reality, this distance here is going to be the same as this distance there, and this distance here is going to be the same as that distance, and they're going to form right angles at that point. And so as long as you understand the concept, I'm fine with just sketching it and estimating it. And so if you don't understand the concept, then you can get back with me and let's work on it a little bit. And so today's lesson, what I need you to do, it's on page 502. And I need you to do 1 through 6. Those are where you're actually flipping the image. So you're actually going A, B, and then you're getting the A prime and B prime. So do 1 through 6. Try number 7. That's just a definition thinking one. And then do 11 through 15. So 11 through 15, 11 through 14 is where we're trying to get the line. They give you the image and the pre-image, and they want to get the line. And then number 15 is just an explanation problem, definitions, to make sure we have the definition clear. So your final assignment is page 502, 1 through 6, number 7, and 11 through 15. Hope y'all have a good day.